Hi everyone, this is Choi again. Let's continue to discuss about Chapter 7 final exam with the documentation that I passed out last week. Test Bank Chapter 7. And the previous slides explain about the multiple choice questions, by the way, and in here we highlight some of the questions in problem side. And the first one, chapter question number 7, as I illustrated, I'd like to highlight the question 7, 8, 20, 21 for the final exam this coming Thursday night, 4 o'clock actually. And question number 7, I had a little kind of a different answer as compared to the publisher's answer. By the way, you can use the Excel sheets for those 5, and I come up with the let's take a look at. I come up with the standard deviation that is 2.73. Actually, the x bar sigma, that is what I come up with, the 5, in this case sample size, and minus actually population size 5, and then sample, in this case 2 will be withdrawn, and then 5 minus 2 divided by 5 minus 1 by following the equation, and then I have a 2.75. This is 2.73, and then divide by root, in this case 2. Then come up with the likely 3 over 4 and multiply by that one. I come up with 1.936492, something like that, which is 1.671777. I'm talking about the question number B. The sample of size 2 will be drawn from the population. They use the answers in part 2, part A, to calculate the expected value and the standard deviation of the sample distribution of the sample mean. But the publisher's answer is for some reason 1.5. Anyway, that's what I have in question number 7. Actually, question number, before we move to another question, the question number C, find all the samples of 2 workers that can be extracted from this population, and then it will be likely AB, AC, AD, AE, BC, BD, BE, CD, CE, and D. And that's why we did it, I remember a long time ago in the class, to get the possible samples with the in this case the without replacement, and then we can we can have their in this case the sample mean for each sample, so it's not a big deal. Question number 8, the average weekly earnings of bus drivers in a city are $950, and then with a standard deviation $45, and assume that we select a random sample of 81 bus drivers In this case, the answer A on A. Let's take a look at here. And the answer A is expected value. In this case, the compute the standard error of the mean, that is 5. And question number B is what's the probability. Let me switch to another reading glass. What's the probability that sample mean will be greater than 960? And you can now likely draw a situation950. $950, and then we are concerning on 960 right there. And the question is, what's the probability that sample mean will be greater than 960? So we want to get this area, and that will be coming out from the z value, that is 960 minus mu 950 and divide by standard deviation, in this case 5, so it will be 2. So you can go to the table 1 z table using 2. That is the 0.72. This is 7. Okay, so this area will be from likely equation equal to 1 minus this one. So that one, different color, that is 0.02 0.0228, like that. Right. Okay, let's move to another question. Question number 20. The question number 20 is with the probability question, related question. The 500 employees in a firm, and 45% are female, and a sample of 60 employees is selected randomly, and then we need to calculate the standard error of the proportion. And that case, likely the proportion, standard error of the proportion will be, in this case, P bar, that is 500, which is the sample size, actually population size, and then we throw the 60 sample size, so it will be 499. This one is a population n minus the sample small n divided by 500 large n minus 1 by following the equation discussed in your textbook. And a proportion, in this case we're talking about 45%, and complementary will be 0.55, which is 1 minus 0.45, that is 0.55. And then we're talking about the sample of 60 employees, so come up with the 0.06031. And again, you can have a normal distribution curve. In this case, the question number B, what's the probability that sample proportion of females in between 0.4 and 0.55? So we are talking about the 0.45 as a mu, and we're talking about 0.4 is right there, and the other one is 0.55. So the bottom line of the question B is we want to calculate actually, you know what, this guy's right there, okay, right this area. So I came up with the point. You can take a look at the Z table. So bottom line is we take all this area and minus this area. So let's say this one is all of them is like a A field, and then this one is a B field. So from the table, basically A minus B, which is the one that we're talking about right there. Okay. Question number 21 is the same kind of a deal, and in this case, let's see, the 10%, which on 10% of the items produced by a machine are defective. So random sample of 100 items is selected and checked for defects. A, determine the standard error of the proportion. So in this case, why don't we draw the normal bell curve? We are talking about likely 10%, 0.1, and the other one will be 0.025, which is 2.5%, and the other one that we're talking about, 13%, somewhere 0.13. Okay, so you may draw something like this. Then I come up with the answer point, in this case 0.03 is standard error of the population. In this case, you know, the proportion likely 0.1 multiplied by 0.9 supplementary and divide by 100. Okay, so I come up with a 0.03, and then in B you need to calculate the z-score on that case p bar. That will be, one of the example will be 0.13 minus 0.1 and divide by the standard error of deviation, in this case 0.03. Okay, that gives the kind of 1, and you can take a look at the table 1 with a z equal to 1. So you can figure it out. Likely question number B, what's the probability that sample will contain more than 0.25? So all these areas, something like that, and that is, I came up with the 0.9938, and the other last question C, the probability that sample will contain more than 13%. We're talking about that area right there, and came up with the 0.1587 according to the table value of the z over 13%. Okay, so those are the questions that I like to highlight for your final exam this coming Thursday night, starting at 4 o'clock. Okay, if you have any questions, then let me